Hi guys, welcome to my channel. Today we'll be solving the MATE's 12th challenge. Let's get into the question. So the question is permutations 2. So to explain the question, they will give us array of numeric integers. So we have to return array of all the possible permutations of that given array. So this should be unique, and also take care there are non-unique elements in the input array. So we have to give out the output of all the possible permutations of the given array. So let's see how we can solve this question. The algorithm will be like this. For example, let us take this as our input, 1, 2 and 3. Okay. So now we will be recursively finding all the possible combinations of the permutation. Okay. So for that, our approach will be, in the first time when we call our function, we will call this array along with the index I, where I represents the index of the current element. So that will be 0. So what we will be doing, we will be swapping this index along with all the other indexes which are coming after them, including this. We'll be swapping with this, and we'll be recursively calling it again, and also we will be swapping this element with this element, and we'll be recursively calling it again, and also we'll be swapping this element and along with this element, and we'll be recursively calling until we reach the index here. Okay, until the I becomes equal to n minus 1, we will be continuing this operation. Okay, let's call it recursively. Now in the first recursive call, our I is 0, and this is our input array. In this one, the for loop will run. As I told you, first for loop will run, and our j in that for loop will become j will be 0. So we will swap I with the 0 ith index and jth index, and we will call it again. So ith index and jth index are same, so our call will be be again the same input array, since we swapped this with the same index. And in the second call, here while we are calling, we will increment the I. Now the I will become 1. Okay. Now in the second call, the j will be 1. The for loop will be in the 1th index. Now we will be swapping the 0th index and 1th index, and we will be calling it recursively. Now 0th index and 1th index, if we swap, we will get 2, 1 and 3. Okay. Similarly, in the next, the for loop iteration would have reached j is equal to 2. Now we will be swapping the second index with the 0th index of I. Now while we swap that, our 1 will be swapped with 3. So the values will be 3, 2 and 1. Okay. So in each case, while we are calling, our I will be I plus 1 of the previous I. So here the I will be again 1. Here also the I will be 1. Okay, since the previous I was 0. Now we will check whether I is equal to n minus 1. Is the I equal to n minus 1? N minus 1 is 2. Is it equal to 2? So it is not. So then we will continue the same thing what we did earlier. Here our for loop will start from I is equal to 1 to end, because our I is 1. So now in this case, the first for loop will have j is equal to 1 as our value. So we will be swapping the 1th index with the ith 1th index, so they both are same. So we will not do any swapping. So it will be like this itself. Since we did the swap for ith index to jth index, we will do nothing. In the second iteration, we will be swapping the ith and the next j index. The next j was 2, So we do a swap between first index and second index. So we get 1, and now when we swap 2 and 3, we will get like this. Okay. In this case also, in this both the calls, we will be calling with I is equal to I plus 1. So our I in this case will be 2. Okay. Similarly, in this case also, the I would have been called with 2. Okay. Okay, let us see for this. Similarly, here also, first call will be swapping with j is equal to 1 and I is equal to 1. So the array will remain as the same array because our j was 1 and we swap 1 with 1. And in this case, our j is 2. So we will swap this and this. So our array will be like 2, 3 and 1. Okay. In this case also the same thing. First time j was 1 because we are doing running our for loop from starting from I is equal to 1. So now again this array will remain same, 3, 2, 1, and this other array will remain like this because we swap 1 and 2. Our next array will be like this, 3, 1 and 2. In each of these cases, our I was 2. So we will check this condition whether our I is equal to 2 or what. If our I is equal to 2, then we will add this in our result array and we will break the loop. We will not continue further. So this will be in our result, this will be in our result because I is equal to 2. So these everything which is in this depth will be in our result. So these are our results. Okay, let's try to implement this program and take care of one more thing. If there can be duplicates. So if this 2 is 1, then here wherever we see 2, it will be 1, right? That time we have to take care of the duplicates. So if you can see this and this are same. So we should not include both. 113 and 113 are same. So you can use a set instead of a list for storing our result. Okay, let's see how we can implement it. I'll use Python to implement. So first we will have a result. As I told, we will use a set to store the result, and we will compute and keep our length of the given input. Once we have these two values, then we will be returning our result once we find it. So you can also first you can keep it as a list, then you can convert it to a set and return to eliminate the duplicates. Okay, now we will fill the result. Okay, to filling the for filling the result, as I was telling, we will have one variable called IE, which will indicate where we are starting from, this I, and one more is our list, modified list or whatever list. So each time when we are calling with a modified list here, etc. So for that we will be calling with one list. So let's call it LST, something like this. Now what we will do, we will check, first we will include this n inside our function which is defined outside. So now what we'll do, if our I is equal to n minus 1, then we will be storing it in our result. We will be appending this current list into our result as one of the permutation. If not, then we will not continue. If not, we will be running a for loop for j in range till n, but starting from like this. We are starting from I, right? We are starting from I. Wherever I is there, from there we will start our j. So if you can see, the j was 1 and 2. So starting from I. So we will start from I to the end. Okay. Here in each case we will temp list, we'll create a temp list out of our original list, so that it will be a deep copy. So we are deep copying the list, and we are swapping the elements. We will swap the I and jth element will in the temp list. So we did our swapping. Now we will call our recursive function with this swapped temp list. So we will call it, but we will increment our I. Each time here I was 0, when we called, we incremented I to 1. When we again called, we incremented our I to 2, right? So that way we are incrementing it. This way our result will get filled up in our res variable, but it will be having duplicates. So we are, to avoid duplicates, we are removing the duplicates by converting it to set. Let's call this function in from our main method. So we will call this function with our given input and I as a 0 for the first time. So let's try to run this. Okay. So I have to what is this selling? Set, return set. Okay, now what is this error is, we cannot convert a set while we are having a list. So let us typecast this to tuple. Okay, then we will be able to convert it to set, because tuple is immutable. We cannot change the tuple, so we can be able to convert it to set. So now it is working fine. Let me try to submit it. It got submitted successfully. Thanks for watching. See you in the next video.